Good morning, students. In last class, we have started the equilibrium chapter, and in chemical equilibrium, you will get a law which is called law of mass action. So, what is law of mass action? According to this law, the rate of a reaction, is directly proportional to the product of the multiplication of the active masses. Active masses means you can write concentration. Active masses of the reactant, comma, is raised to the power equal to its stoichiometric coefficient as represented in the balance chemical reaction. So what is this law? According to this law, the rate of a reaction is directly proportional to the multiplication of the active masses. Active masses means concentration of the reactants, is raised to the power equal to its stoichiometric coefficient as represented in the balanced chemical equation. So as you have got, when a reaction is said to be equilibrium, when the rate of forward reaction become equal to the rate of backward reaction. Now what is the rate? If you want to find out the rate of a chemical reaction, then you can represent the rate of a chemical reaction by applying the law of mass action. So what is this law? Suppose this is a reaction A plus B, it gives C plus D, and the reaction is reversible in nature. Here A and B are said to be reactant and C and D are said to be product. According to this law, if you want to represent the rate of the reaction R, rate of the reaction is represented by small r, the rate of the reaction is directly proportional to the multiplication of the concentration of reactants. So what are the reactants A and B? So the concentration is represented by square bracket like this. This square bracket represents concentration. So if you write A inside the square bracket, this represents concentration of A into concentration of B like this. I mean, according to this law of mass action, the rate of a chemical reaction is directly proportional to the multiplication of the concentration of reactants. It do not depends on product, it mainly depends on the reactants. And if you want to remove the proportional sign, then a constant will come, and this constant is said to be the rate constant, K into A, concentration of A into concentration of B. This K is called the rate constant. Now what about this? It's raised to the power equal to its stoichiometric coefficient as represented in the balanced chemical equation. For example, this is one of the reaction A of A plus B of B. It gives, suppose, X and Y. This small a, small b, they represent the coefficient for the balanced chemical reaction. If this type of coefficients are present, I mean if number of moles are present, then the rate of the reaction is directly proportional to the concentration of reactant A into B. Since the coefficient of A is small a, so this A should be power like this. the coefficient of B is small b, so it should be power in the rate expression. So that is why you have written, according to this law, the rate of a chemical reaction is directly proportional to the multiplication of the concentration of reactants is raised to the power equal to its coefficient, as in balance equation. For example, this is one of the reaction N2 plus H2, it gives NH3. I mean, when nitrogen and hydrogen gas react, it produces ammonia. Now in this reaction, the reaction is not balanced. If you want to balance this reaction, if you put 3 here, if you put 2 here, then the reaction will be balanced. Now after balancing, you will get some coefficient. Inside hydrogen you will get 3 coefficient, inside nitrogen 1, here ammonia contain 2 coefficient. So if you want to represent the rate of the reaction according to this law of mass action, R is directly proportional to the multiplication of the concentration of reactant, I mean concentration of nitrogen into concentration of hydrogen. Since the coefficient of hydrogen is 3, so it should be power like this. Nitrogen coefficient is 1, that's why this 1 should be the power. So this is called the law of mass action. According to this law, the rate of a chemical reaction is directly proportional to the multiplication of the concentration of reactants is raised to the power equal to its coefficient. So this law is called the law of mass action. Now there is a law of chemical equilibrium also. Now I'll give you law of chemical equilibrium. Law of chemical equilibrium. Now what is this law? Consider, this is called law of chemical equilibrium. Consider a general reversible reaction. Consider a general reversible reaction. A of A plus B of B it gives X of X plus Y of Y. Suppose this is a reaction and the reaction is reversible. Here capital A and B are the reactant and capital X and Y are the product. This small a, small b, small x, small y, they represent the coefficient in the balance equation. Now if you want to write the rate of forward reaction, you know, when you consider the forward direction, A and B are the reactant, then you can write RF, I mean rate of forward reaction, is directly proportional to the multiplication of the concentration of reactant, I mean concentration of A into concentration of B. Since they contain coefficient A and B, so they should be power like this. So this is the rate of forward reaction. You can apply, you can write the rate of forward reaction by applying the law of mass action. Now if you want to remove the proportional sign, then a constant will come which is called rate constant. You can write Kf A to the power A, concentration of B to the power B. This Kf is called rate constant for forward direction. Similarly, the rate of backward reaction, RB is directly proportional. When you consider the backward direction, then X and Y will be the reactant. So RB proportional concentration of X into concentration of Y. Since coefficients are present, so to the power X to the power Y. And when you remove the proportional sign, a constant will come Kb into concentration of X to the power X, concentration of Y to the power Y. This Kb is called rate constant for backward direction. So this is the rate for forward direction and this is the rate for backward direction. Now you know, at equilibrium, when the reaction is at equilibrium, then rate of forward reaction becomes equal to rate of backward reaction. I mean, when the rate of forward become equal to rate of backward reaction, then the reaction is said to be at equilibrium. So RF means you have got Kf of concentration A to the power A, concentration of B to the power B This is equal, RB means you can write KB concentration of x to the power x, concentration of y to the power y. So when you do Kf by Kb, then you will get concentration of x to the power x into concentration of y to the power y divided by concentration of a to the power a into concentration of b to the power b. This Kf by Kb, I mean rate constant of forward reaction by rate constant of backward reaction, this you can write as Kc. This you can write as in terms of Kc also. So Kc is equal, you can write concentration of x to the power x into concentration of y to the power y divided by concentration of a to the power a, concentration of b to the power b. This Kc is called equilibrium constant. Equilibrium constant. Here C is written because the equilibrium constant is represented by the concentration. That's why it is called Kc. I mean equilibrium constant in terms of concentration. So what is equilibrium constant? Equilibrium constant means nothing. It is the ratio of the multiplication of the concentration of products to the multiplication of the concentration of reactants, each raised to the power equal to its stoichiometric coefficient. Always you do product by reactant to determine Kc. So this equilibrium constant Kc is very important. When a reaction is at equilibrium, then the equilibrium constant you can apply the Kc for the reaction, and that when you represent the Kc for the reaction, it is nothing, it is the multiplication of the concentration of product divided by multiplication of the concentration of reactant, each raised to the power equal to its stoichiometric coefficient.